Hey, let's go ahead and get started this evening. Welcome, everybody, to our webcast tonight with Dr. Jennifer Heldmann, who currently is at NASA headquarters. She is part of the LCROSS team, and that's what she's going to talk to us about tonight. And then when she gets done, after a few minutes, we'll open it up for questions from you all in the audience. So please go ahead, take it away, Jennifer.
Okay, I'm going to flip on the hands-free again, so if there's feedback or some issues with the audio, just let me know. So first of all, thank you to LPI for hosting this. This is really great. It's really fun to have the opportunity to talk to people about some of the really cool lunar mission work that's going on right now. As Andrew mentioned, I'm at headquarters, and I'm also normally based at NASA Ames Research Center, which is where LCROSS is headed out of. And so, for those of you that haven't heard yet, LCROSS stands for the Lunar Crater Observation and Sensing Satellite. And so I just want to take a few minutes in the beginning to give you a little overview of what LCROSS is, why we're doing it, what led us to this, and what's going to happen in about 15 days from now. And then open it up for questions so we can talk about it and talk about the bigger picture issues too, if you'd like. So really, the genesis of this came from some missions that happened back in the 90s. The Lunar Prospector mission returned some interesting data about the moon. One of the things that Lunar Prospector found is that there's enhanced hydrogen near the poles of the moon. And we don't really know what the form of that hydrogen is. Maybe it's water, maybe it's hydrated minerals, maybe it's solar wind. We don't know. But it's near the poles. That's interesting. And then also, we know that near the poles of the moon, there are these regions in the bottoms of craters, some areas where there's permanent shadow, where the sun has not shone in these areas for billions of years. So, therefore, very, very cold. And so, they're very, very cold. This would be a good cold trap or a good place where water ice could accumulate. So there's been some conflicting data that's come in. There's been some radar data that's indicated maybe it's ice, maybe it's not. There's really not consensus in the scientific community at this point as to if there's ice in these permanent shadows, if there is, how much is there, where it's located. And so we really need to have more data in order to understand this. And it's really amazing because you can go outside and look at the moon, and you can see the object right in the night sky with your naked eye, and yet we don't know if there's water ice near the poles of the moon. So it's just one of those basic fundamental questions that's important not only for science, it's scientifically very interesting because if there's water ice there, how much is there? What does that tell us about the history of the moon, etc.? And it's also interesting for exploration. So if NASA's talking about sending humans back to the moon, if you have water ice there, that could potentially be a very valuable resource. So we need to do these first steps and try and figure out if it's there and in what quantities and where. So enter LCROSS. So LCROSS is it's a very low cost, fast tracked mission. It's just been in development since about 2006, so that's pretty quick in terms of developing spacecraft missions. And what LCROSS is, it's a lunar impactor. So we are actually taking the upper stage of the launch vehicle. We launched in June of this year, taking the upper stage, venting out all the fuel, and so now we're left with basically a big empty metal can. And on the end of that empty metal can, we attach a small little spacecraft, and we call that our shepherding spacecraft. And so what we did is we launched that, and we launched along with the Lunar Reconnaissance Orbiter, or LRO. It's our sister mission. We both launched on the same rocket, so that's a very cost-effective way to get into space. LRO has since gone on. LRO is in orbit around the moon, returning a tremendous amount of data already. There's been some interesting results that have come out of LRO thus far. So LRO is in orbit around the moon for a few years. And LCROSS has been orbiting the Earth. Actually, we're in a very big looping orbit. And we are just now coming up, and we're 15 days away from lunar impact. So we will be impacting at the south pole of the moon in one of these regions of permanent shadow. And about 9 hours and 50 minutes before impact, we have the Centaur, the upper stage of the launch vehicle, which is that big empty metal can, that will separate from the shepherding spacecraft. And so the Centaur will go in first and will impact the moon first. And then following 4 minutes behind is the shepherding spacecraft, which has a suite of instruments on it that will be watching that impact. And so you have the Centaur that impacts, kicks up a big plume of dust, debris, ice, if it's there, kicks that up into the sunlight. We take our measurements, relay that data back to Earth, and then the shepherding spacecraft is also a second impactor, so you actually get two impacts for the price of one, which is pretty clever. So we're going to impact in permanent shadow, and this is our way of doing the quick and dirty way of ground truthing what is actually there in these permanently shadowed regions. And so we'll be observing not only with the LCROSS shepherding spacecraft with its 9 instruments, but also from a suite of observatories on the Earth and in space. So we have a very large ground-based observation campaign that's going on. So telescopes on Earth will be observing, LRO will be observing. We have several satellites that are in Earth orbit, like the Hubble Space Telescope, the ICONOS satellite, the Earth Observing Satellite, et cetera, et cetera. So we're going to have as many eyes as possible watching this impact. And then we'll take all of that data together and look and see if we can try and determine what actually is the material, what is in those permanently shadowed regions, and do we see the signatures of water in that plume. So that's the quick and dirty gist of what's going on with LCROSS. The impact itself will be on October 9th of this year, so that's 15 days from now. It'll take place at 4:30 a.m. Pacific time, so that's 7:30 a.m. East Coast time. And so for amateur astronomers that would like to observe the impacts, we expect you should be able to see the impacts in a 10 to 12 inch telescope. So you really want to be, in the United States anyway, west of the Mississippi, because on the East Coast, well, we've already been dawn, the sun's already up, very difficult to observe. But if you go further west, it's still nighttime and it's still dark, and so you can still observe the moon and try and catch these impacts. So we encourage you to do that. There's also a number of science museums and planetariums and observatories that are having special events. So we have a place on our website where all different events are listed, so you can find something that's near you if you want to go observe. We'll be actually broadcasting the spacecraft data live on the web, so you can see it as soon as we see it in the Science Operations Center. We'll be broadcasting the camera data. So as that shepherding spacecraft follows 4 minutes behind that first impact, you'll be able to see it just in real time like we do. And then we'll have more data coming back from the shepherding spacecraft as well. And just a few quick words on what I do on the LCROSS project. I'm on the science team for LCROSS and also the payload team, helping to calibrate the instruments and do environmental testing and make sure that those instruments will work in space. And I'm also coordinating the observing campaign. So there's people on LCROSS that have lots of different duties. So we're a very nimble team trying to get things done, and we're looking forward to what's going to happen in 15 days from now when we actually have these impacts. So that's the brief overview. Is that you want? I can talk forever about this, Andrew. So you can just cut me off whenever.
Yes, for sure you could, Jennifer. We'll take some questions right now. In fact, does anybody out there have a question? Okay. We had some actually were sent to us ahead of time. One is if there is no ice signature in that plume that gets kicked up, does that mean there's no water on the moon?
Yeah, that's a very good question, and that's something that we've talked about a lot within the science team. So we're in our site selection, we are trying to go to somewhere where if there's water ice there, we would expect it to be there. So in our site selection, we consider things such as the hydrogen content that's measured by both the Lunar Prospector and also the Lunar Reconnaissance Orbiter has the LEND instrument on it. So we're looking at that. We're looking at radar data to try and understand, what's going on, where we might expect to see the ice. We're going in a region of permanent shadow, which would be cold, very cold in order to preserve the ice. And so with LCROSS, we'll get 2 data points essentially. We'll get that first impact point where the Centaur hits, with the second where the shepherding spacecraft hits. If there's no water detected in those two impacts, that will just tell us there's not water at those 2 locations, because the footprint of the hydrogen signature is much, much larger than the size of these impacts that we're going to create. So that may tell us either there's not water there in that region, on a broader scale, or it could tell us that the water, if there is water ice there, that it's heterogeneous, it's kind of patchy and spread out, and so maybe it's only in certain locations and not in other locations. So that's one of the unanswered questions that we don't know right now. Is it heterogeneous, or is it kind of smoothly, broadly mixed in? And we don't actually know. So either way, we're going to learn something about what's going on in these permanently shadowed regions. So either if it's water or it's not water, it's still a scientifically significant result. We'll also be able to look and see if there are other types of materials there, organics, hydrated materials, and try and understand, because we've never actually gone to these polar regions before. If you look at where Apollo went and the earlier Surveyor and Luna missions, et cetera, where we've landed on the moon before, it's been pretty much in the equatorial region. And so the poles are really unexplored areas. And so since we haven't actually been able to go there yet, this will be our first time to actually ground truth what's happening there. And so we have spectrometers on the shepherding spacecraft. We'll be able to get spectral data, be able to get compositional data, et cetera, et cetera. And so we anticipate that whatever ends up coming out of this, we're going to learn something. And that's one of the exciting things, is that that's why we do exploration. We don't really know what to expect. And, we use our best estimate based on the data that we have, but we don't have all of the information yet. And so I think that's one of the exciting things, is what are we going to see, at 4:30 in the morning, California time.
Okay, I got another question here, and after this one, James, you go ahead and you can ask yours. Jerry in the audience says that he's got a question, but he's doing an event in San Diego with the San Diego Astronomy Association. They're expecting about 300 to 500 visitors.
Wow.
For the impact event. So that's pretty cool.
That's very cool.
And his question is, for his event, we would like to be able to verify the impact occurred successfully for the audience. Is there a plan to tweet the status of the mission?
Yes. So first, Jerry, I haven't checked, but I hope that your San Diego event is on the LCROSS site, because we're referring, a lot of people write into us and say, where can I go to observe? And so we point them to this resource. So hopefully that's listed there, because that would be fantastic. And regarding the tweeting of the impacts, yes, we will be live tweeting. You can verify it in a few different ways, and we've specifically set this up so that there are a few different outlets where you can get information. First, there will be the live streaming of the camera data from the spacecraft, so you can watch it in real time, and if there's a plume and we see it, you'll see it at the same time. We'll also be doing live tweeting, so there will be status updates throughout the entire night. We've been doing updates regularly throughout the mission, and that will increase in frequency, particularly starting about 10 hours before impact. That's when we'll really start, doing more of the tweeting. That's when a lot goes on, because that's one of those big events that you want to know that it happened, right? That the Centaur and the shepherding spacecraft actually separated. So that happens 9 hours and 50 minutes before impact. And then throughout the rest of the night, we're going to be tweeting with regular updates from the Science Operations Center that will be then sent out so that the general public can know what's going on. So it's our goal, and this is in the current plan, is to be as transparent as we can, send out the information in real time, let everyone know what's going on, not only to keep people engaged, but also to help facilitate observations for a lot of people that are planning to observe. And in addition to doing the tweeting for the updating, we'll also be sending out the most updated impact time and coordinates for where we'll be hitting. So especially after we do that Centaur and spacecraft separation, then we'll know pretty well, the trajectory that we're on, and we can narrow down even more precisely than we already know the impact coordinates. And so you can expect the absolute final, most updated impact coordinates on the order of 3 hours before the impact. It won't change too much from what we already know and what we'll know about 10 hours out, but all of that information is going to be tweeted out. And we'll also be updating the Facebook status. If you're a fan of LCROSS on Facebook, that information will be going there too.
Yeah, sorry, James, I don't think we heard you. James is going to type that to us, which is perfect. In the meantime, here's another one for you, Jennifer. How is the targeting going? How close to target point do you think you will hit?
Yeah, good question. So we're actually very accurate in our targeting. Right now, we have targeting accuracy on the order of 3.5 kilometers. So that's very, very good. We actually expect to do even better than that. And so any of the target sites that we've been considering are well within our targeting accuracy. So once we're on track, we're on target, we expect that we'll be able to hit the moon. At this point, gravity has taken over, right? And so we're going to hit the moon no matter what. We couldn't not hit the moon at this point if we tried. So we're going to hit the moon, and given our targeting accuracy, we're going to hit in a region of permanent shadow. So, good question. Oh, I can see James's questions.
Okay.
So let me just scroll back. I think the first one is about venting the Centaur. Yes, so we are venting the Centaur. We have been venting the Centaur to get rid of any excess fuel that may have been left over. So getting that thing pretty empty. We've also been doing cold side bakes so that any water that may have accumulated on the outside of the Centaur will be vented, be gone. So the idea is to have the least amount of contamination possible for that first impact. And there have been a lot of studies that have been done. We've assessed this very thoroughly, and that the amount of fuel that may possibly remain within the Centaur in a worst case scenario is well below our detection limits. So we're not expecting contamination to be an issue. To not interfere with the readings. And there was another question I thought I saw. All right, how are you getting the 4-minute separation? So at this point, the Centaur is dead. It's inert. So the Centaur will separate from the shepherding spacecraft. The shepherding spacecraft itself has fuel tanks and engines on it. So we will do a burn with the shepherding spacecraft to slow ourselves down a little bit. And we actually do a 180-degree flip, because that way we have the payload instruments facing towards the Centaur, watching it go in. So the sequence of events is we have separation of the Centaur and the shepherding spacecraft, flip the shepherding spacecraft over, do this burn to get our separation out, and we'll have the cameras on so we can actually watch the Centaur as it separates, and that way we can have visual confirmation that we have a clean separation, and we can actually watch that thing go in. I see another question. Any photos of what the site looks like before impact, and where can we find those? So that's a good question. And the answer is yes. We have, as part of the observation campaign, it's actually been really interesting because it's worked out quite well, and that we have the amateur astronomer community and the professional astronomer community working together. Because when you have the very large telescopes, like think of the 10-meter telescopes in Hawaii and whatnot, it is not trivial to point at the moon. It's very difficult to actually point at the moon and get in the right spot. And another thing that makes it even more difficult. I think the audio just went a little crazy. Good now? Okay. So what makes it difficult is the libration of the moon, because the moon tilts, ever so much. It's not a lot, but it's enough to very dramatically change the features on the lunar limb. So it's very difficult, especially down near the poles where we're targeting. It's very difficult to identify where you are, especially when you're using those large telescopes, because you have to look at the geometry and what's changing. And is this a ridge? Is this a crater? And they're all warped a little bit from what you might expect them to see. And so trying to figure out where you are and practicing crater hopping instead of star hopping, but they're actually crater hopping and going from ridge to ridge and having waypoints. So in order to help with that, the amateur astronomers have been taking images of the moon in different libration states and sending that along to us so that we have maps and so we can do our pointing. So that's been one way. Second way is we have very good, better than we had before, laser altimetry data of the moon, both from the Japanese Kaguya mission and also NASA's LRO mission from the Lola instrument. And so we're taking that data and actually creating visualizations and renderings of exactly what the moon will look like at the date and time of impact. So we can see what will look like at that libration, at that phase, and so that people can use that for their pointing practices. About last week, week and a half or so, we are in about the same phase that the moon will be in. I guess it was 2 weeks ago. The same phase that the moon will be in on the night of impact. And so this is the closest it will get to the same phase and the same libration on the actual night. So a bunch of the observatories did observing runs and have been creating mosaics of the moon in those regions. And so we posted one of those from New Mexico State and NASA Marshall on our website, on the LCROSS website. It's www.nasa.gov/LCROSS. And so you can go there, and we've labeled which craters are which, so you can see what it'll look like in the projection on the sky. So there's been a lot of work that's been going into this, trying to practice, and a lot of on the actual night as well. The teams will be taking a lot of the before images for pointing purposes, but also for calibration purposes, and then for doing image subtractions later. So it's really good to have before, during, and then after images. So there's been a lot of work that's been going on in that front. And if you're interested, there's also a Google group that we've set up specifically for the amateur astronomers, and they've been very, very active in talking about how to observe, where to observe, what to observe, and have been posting some of the sample data. So there's a tremendous amount of sample data that's on the Google Groups website, which anyone can join. There's a link to it from our website, from the LCROSS website. And we've also just launched an LCROSS Citizen Scientist website as well. And so this is where we're encouraging folks to go out and observe the impacts and upload your data to us at NASA, because we are planning in the science team to take as much information as we can and synthesize all of that information. So getting as many telescopes watching as possible. So even from the amateur community, which many people have very sophisticated telescopes and instruments and whatnot. And so if we can get as many different vantage points, different types of instrumentation at different wavelengths, and try and combine that together to get the most complete story, that's what we're looking for. So you can upload that data on the Citizen Science site. And there's also a discussion group and a blog and all types of things. And there's some sample data that's been uploaded there. So yeah, it's been very active. That was a good question. I see another
Do you see
question.
that one there? Do you see that one from William Higgins?
Okay. The last 4 minutes of the LCROSS spacecraft life are the most important. What were the challenges making sure the instrument data gets out just before the second impact? Yeah, that's a good question. And we kind of joke, although it's not that funny, in the team, that this is a lot of work for 4 minutes of data. So it's very important that we get that 4 minutes of data back. And so we have the spacecraft, we already have the entire plan worked out. There's 9 instruments on the shepherding spacecraft. We have a visual camera for context images, seeing the plume. We have 2 mid-infrared cameras that'll give us thermal information. 2 near-infrared cameras will give us spatial distributions if there's any water vapor there. 2 near-infrared spectrometers, UV vis spectrometer, and then a total luminance photometer to catch the flash, the first sign of the impact. And so there's an entire sequence that's already worked out for that data to be collected and then to be sent back and downlinked. We're using the DSN so that we can get that data back. And so the comm folks are very sure that we'll be able to get that information back. We've been doing testing throughout these few months where we've been in orbit. We've done several Earth looks where we turn the spacecraft and look at the Earth, can demonstrate that both the instruments work and also the relay of the data works just fine. We did a lunar swing by 5 days after launch, tested out the payload, tested out the comm, et cetera, et cetera. We're pretty sure we'll be able to get the data back. We've been testing that out ad nauseum, and everything has worked fine so far, and things have been optimized, making sure that we can get that data back in those 4 minutes, because as you rightly note, after 4 minutes, the shepherding spacecraft itself is a secondary impactor, and so that will be the end of that, and we'll know that immediately in the Science Ops Center when we lose all our telemetry. Any before pictures from a lunar spacecraft? Yes, there are actually. The Japanese Kaguya spacecraft was able to take some images, so there's some before. And also, we've been working very closely with the LRO team, the Lunar Reconnaissance Orbiter, because they have been doing characterization of the impact site before we impact. So they have been specifically doing that and working with us, helping with our site selection as well. They'll be observing during the impact, and then very importantly, they're the only spacecraft that will be in lunar orbit to do post-impact characterizations. So they'll be able to follow up as well. So yes, we are working with another. There will be more information coming from lunar orbit.
Question earlier. We had a question earlier. We missed here. Asking, can you share the status of the health of the LCROSS instruments?
Yes. Yeah, they're good. They're all working. We just did our last Earth look last Friday, And part of the point of doing those is to turn the payload on, test systems out, make sure everything's working okay. And our instruments seem to be fine. So since we're 2 weeks out now, so we've made it since from June is when we launched, and then impact will be in October, and we're 15 days away. So the instruments seem to be working just fine. So we've been quite pleased with the payload. And it's also interesting. It's a good, not only for scientific reasons, it's great that the payload's still working and the instruments are still working, but it's also a test for NASA as well, because these instruments, 8 out of the 9 were commercial off-the-shelf instruments that we bought from companies instead of developing them from scratch and building them ourselves. We went to companies that had instruments and we bought them and we space rated them and we tested them and we put them through all the environmental testing. And so assuming that these instruments continue to work for the next 2 weeks, this is really a really important test bed for NASA. Is this a way that we can go for lower cost in order to still achieve our objectives by getting commercial off-the-shelf instrumentation? NASA, or LCROSS, is a Class D mission in NASA speak. So Class D means we can accept more risk. Essentially, it's a low-cost mission. More risk is tolerated. And so this is one of those things where, because this hasn't really been done before. You go out and you buy 8 of your instruments from companies and then test them out and then launch them into space. And so they've been working beautifully. So we've been really pleased with that so far. So hopefully you'll stay tuned for the next 15 days and hopefully things will still work. And you'll know right away because we'll be broadcasting on the web, so you'll be able to see it. So yeah, we're pretty open about that.
Will LRO be situated to image the plume?
Yeah, we've been working with LRO right now. Well, we have been for quite a while to figure out where they will be. It hasn't been completely finalized yet, but they will probably be about near the plume. They'll be able to see it. And one of the issues with LRO is that LRO is not designed to watch this impact. So they can't slew really, really fast. But they'll be able to point their instruments towards the impact itself and collect data during. So they're going to be in an extremely important vantage position in order to get the information during the impact. And it's also really important that they're going to be collecting data after the impact. So afterwards, they have instruments, they'll be able to image the crater that's formed, or they'll be able to do their laser altimetry and get the profiles of the crater. They'll be able to monitor the thermal evolution. They'll be able to look and see if there's any frost that's been deposited on the surface. And so they're the only ones that are there that can do that on multiple orbits. So they're doing before, during, and after data. So it's been good working with them.
It's another audience question.
Oh, there's one about the emergency.
If you could.
That one?
Oh, there's one right above that.
Oh, the spectrometer and the infrared spectrometer calibration methods. Yeah, so we, before we launched, when we had the instruments around the ground, we did the calibrations at NASA Ames in the calibration lab. And so we use standard techniques for how instruments are typically calibrated for spaceflight missions. You take them into the cal lab, you look at a known source, known reflectivity, collect the data back. We know what the signal should be. You compare that with what the instrument response is, and then you can get a sense of what the flux is per data number. And so we're able to calibrate that way. Also looking at a known source with known lines, indicative of different types of materials, and then you can do your wavelength calibration that way. So we've been able to calibrate the instruments in all the normal ways you calibrate any other instrument that way. Calibrating the cameras, looking at different light sources, different fluxes, so you can get an idea of brightness and how the instrument responds. Calibrating the mid-infrared cameras by looking at different temperatures, to get the calibrations for how the instrument responds, looking at different temperatures and what the data numbers are for that. So that's all been pretty standard calibration techniques that we did before. Yeah.
Okay, and then James asked another question.
Yes. Yeah, that's a good question. So there was, a few weeks ago, the mission guys decided to call a spacecraft emergency. So what happened is LCROSS has only been scheduled to be in communication with the Earth every 3 days or so during its cruise phase. So on one of the regular, coming back into communications and checking the health of the spacecraft, they saw, wait, something's not right. What had happened is there was an error that was sent to one of the inertial reference unit inside. And so what it did, that error automatically kicked the spacecraft into star tracker mode, which is the way, the spacecraft has a way of keeping itself on target. It knows where it needs to go, especially when it's not in comm, it does it by itself. And there's just inherently more noise in the star tracker mode. And so what had happened is the spacecraft used up more fuel than we had planned on, than we had anticipated, because it was just continually readjusting itself to stay on track in this mode. And so they shut that down, and there was nothing that happened to trajectory. It was fine. It stayed on. The only thing was that it used up more fuel than we thought it would. So they went in and put in some mitigation strategies so that we won't see that again. It was a very rare occurrence. This hardly ever happens, but it did. And the issue, where we stand right now is we're fine with fuel. We have positive fuel margin, so there's no issues there. We still have positive prop margins on us, so we're still targeting where we wanted to target, and we'll still have plenty of fuel to get where we need to go. So they took it out of the emergency mode. The reason you say it's an emergency is right, so that you can get more DSN time, so that you can continue your comm, so we can figure what's going on. So it's been taken out of emergency mode. We're back in normal operations, and it's an exciting few days though.
Another question from the audience asking if there are plans to name the new craters.
Oh, that's a good question. I don't know, actually. I'm not sure, because it's true that we will create 2 new craters. I don't know if they're going to be named or not. That's a good question. I'll add that to my list of things to check in on.
And it looks like this might be a follow-up to that calibration question. It says, so there is no on-orbit drift?
Yeah, so that's why we've done the lunar swing by, and we've done several Earth looks, and we did a starfield calibration to look and to see if there was any, if there's any changes that need to happen after we launch, and also not only for the Bohr sighting, but also for the wavelength calibrations. And so we haven't seen dramatic changes at all, but those are certainly things that we can accommodate and count for. So that's why we specifically had built into the plan that we'd be turning on the payload and looking at some known sources throughout the mission, so that we can test that out. So not only testing the instrument health, but also doing calibration activities.
Another one asking, will the gravity of the moon draw back all the moon particles, or will some head towards Earth?
Yeah, that's a good question. So the impacts themselves are not that big when you think about it in the grand scheme of things. So the material that's kicked up will resettle back down on the moon. So it's not going fast enough. It won't be escaping from the moon's orbit. It's not, it'll all be settling back down on the moon, and it'll settle down relatively quickly, on the order of a few minutes. So don't expect anything. We won't be impacting the Earth, or materials won't be coming back to the Earth. Even LRO is fine. LRO is in 50-kilometer orbit. It's well out of the way of any debris that'll be kicked up. So no, material won't be leaving the moon or coming to the Earth. It'll just be settling.
Anybody else out there have any questions?
Yeah, these are good questions. This is good.
How long will we be studying the data?
Oh, that's a good question. Probably for a long time. I can tell you that, so the impact, I'm thinking in California time, because that's where the mission operations is. So the impact in California is at 4:30 a.m. And then at 7 a.m. Pacific time, we have a press conference to show you what we initially saw, do our very first cut of what the spacecraft data told us, and also what the observatory data told us. So within a few hours afterwards, we'll have a press conference and tell you what we can say at that point from what we see in the data. And then we'll be looking at this data for months, if not years after that. The data will be delivered to the PDS, the Planetary Data System. That's part of the plan, so that it's publicly accessible, so that anyone can go in and look at the data. And so we've been pretty open with sharing the data that we collect. And I anticipate that the scientists will be looking at this for a while to come, and teasing more information out.
Now what about LRO? What will LRO's position at impact? And what are the constraints on its vantage point?
Yeah, so that hasn't been finalized yet. We've been talking with LRO quite a bit. Where's the best place for them to be? Certainly, they would like to observe the impacts themselves. So we're figuring out, given where they are in their orbital constraints, where they'll be observing. It's a matter of how far away will they be and when do they cross over, and then they'll come back around. And on their subsequent loops, they'll be doing post follow-up observations. So that's being worked right now, and which instruments will be turned on and that sort of thing. Once we finalize that, I can let you know.
Another one about what is the size of the largest piece you expect to be kicked up?
Yeah, that's a good question. So as part of our site selection, we would like to hit in a region that is relatively flat and has relatively low slopes and doesn't have a lot of rocks or boulders. Because really what we want to do is we want to hit somewhere that's got sort of fluffy material that we can kick up, because we're only going to see things if that material gets ejected up into the sunlight. So, sort of above the crater rim where the sun is shining. So we're specifically avoiding places that have lots of big rocks. So a lot of the material that'll be kicked up will be dust. And if you have big rocks or something like that, it's harder to get them to go very high. So the things that get kicked up are going to be the smaller types of material. So we're expecting to have a big dust plume, essentially, is what we're looking at. And the dust plume may be interspersed. It may have water ice that gets kicked up and then vaporized once it hits the sunlight. So we're not looking at big pieces of rock or anything. And our shepherding spacecraft is actually flying through that plume. So we don't anticipate that there will be big chunks of rock that'll get kicked up high enough to. We're mostly looking at dust-sized particles.
But when will Hubble and Keck data be available?
Good question. So for Hubble, it takes them a day or two to get the data back and processed on the ground. So at the 7 a.m. press conference, 2.5 hours after impact, we won't actually have the Hubble images yet. But hopefully we'll be able to tell that operations were nominal and the data was collected. And that's just how Hubble works. For the Keck data, that should be available right after impact. The plan, we have a very strong team that's working out at Keck, working with them very closely, and they're planning to send us some of their images that they're collecting. So hopefully we'll have those that day. So we should have data from them.
Is ice water? If there is ice water, will it become liquid in a short time? What will happen to this water if it is there?
That's a good question. So if you have water ice and it gets ejected out, lifted up into the sunlight, what we expect will happen is we could catch the signature of the water ice, and then what will happen is once it reaches the sunlight, it will either vaporize, go into the vapor state, and or photodissociate apart and create OH, right? Because water is H2O, so it'll break apart. And so what some of the models are predicting is that we could generate an OH sort of cloud or in the exosphere that could last for a few hours or so, maybe a day, maybe, depending on how much water. So we expect that once that water ice gets lofted up, it won't stay ice forever. It will vaporize and or get broken apart into this OH. So we actually have instruments that are looking to see if there is the production of OH that happens in the exosphere. And that's one of the indicators of water ice being lofted up.
LRO in polar orbit.
Yes, and that has been really great because they've been able to get very good coverage of the lunar South Pole. And so that's been very useful for us, that they've been able to gather quite a bit of data already. Because remember that LRO and LCROSS launched together in mid-June. And so LRO hasn't been in orbit that long. They just got out of their commissioning phase and just started their prime science phase. And so we are taking the data that they've collected thus far to use for our site selection. So that's been very, very useful for us.
Here's a question that was submitted to us earlier through email. Says I will actually asking if they'll be able to see the impact the cloud in their area. The moon should be visible according to SN Pro Plus. I am in Boston, Mass. I believe the impact will occur about 7:30 a.m. Eastern Time.
Yeah. So what we're recommending to folks is that on the East Coast it'll be tough because it'll be daylight already. So it's more optimal to go west if you can. And so sort of west of the Mississippi and out all the way out through Hawaii will be dark, and this is where the optimal viewing will be in the western half of the United States. So what I've been telling people is that if you needed an excuse to go to Hawaii, I recommend you go in October, because then you can go and observe the LCROSS impacts, because that's a really good viewing location, which works out well. It's done strategically because there are so many professional observatories that are in Hawaii. So it'll be tough from the East Coast, but further west in the US is better.
And the ISS crew help with the observation?
That's a good question. I haven't looked into that yet. It depends on what side of the Earth ISS would be on at the time that we are impacting. That's the same issue with Hubble and the other Earth observing assets. So we haven't actually talked to ISS, but maybe we'll look into that. It's a good idea.
There is recent talk about water being found by LRO and Chandrayaan-1, etc. Has this excited the LCROSS team?
Yeah, this is great, and that's a very excellent lead-in, because there's going to be a press conference at NASA headquarters tomorrow at 2 p.m. local time, talking about the new discoveries on the moon from Chandrayaan and a few other teams. And so, yes, it's very interesting, because we've been working with the Chandrayaan team, and specifically the M-Cube team. If they were still in orbit, in lunar orbit, they were going to observe LCROSS, but they're not there anymore. So this data that's coming out is going to be very interesting, because it's actually a very exciting time in lunar science, because there are all these new discoveries. And so, yes, I would encourage folks to watch the press conference tomorrow.
How does this mission compare to the Deep Impact mission? Did you learn anything from that mission that will help you here?
Yes, that's a good question. They are similar in that they both had impactors, and then one of the biggest areas where lessons learned came into play was with the ground-based observation campaign. Because if you remember, Deep Impact was heavily dependent upon that ground-based observation campaign. And so there are a lot of logistical issues and organization issues and how to secure time on these professional telescopes and whatnot that was learned from the Deep Impact experience. And so we have definitely built off of Deep Impact, and it's a nice example of, taking lessons learned from one mission and applying them to another. There's definitely been crossover in that respect.
It is strange that the Apollo instruments did not detect water. Was it because of the technology of the instruments at that time?
Yeah, so what we knew from Apollo, or the Apollo era, is that particularly the rocks that were returned were very, very dry. Very, very low amounts of water detected, very low. And so there's a press conference tomorrow, so I don't want to say too much. But there are small amounts of water that we knew about, but we know that the moon was pretty much bone dry. And so also Apollo didn't go to the polar regions, which is specifically where LCROSS is going. So the polar regions are a completely different environment from the equatorial regions, which is where Apollo went. So, and Apollo's looking, we have rock samples and materials that were brought back, but this is one of the interesting things, is that the environment is so radically different that you might expect different things, in permanent shadow compared to these regions that are in 2 weeks of daylight and 2 weeks of darkness. The moon is a very curious place in that it has so many different environments that you could be in.
Here's one. What made you decide to go into science?
Oh, what made me decide to go into science?
Yeah.
Because it's fun to explore, basically. Because in science, this is the area where you can actually learn about the universe, and you can, discover things that no one else has discovered before. And these things are just waiting to be discovered. They're out there, and we just have to learn about them. And we have to be smart enough to figure out how to unlock the secrets that nature has holding for us. And so I think it's exciting. I think it's one of those jobs where, you don't actually know what you're going to be doing. With this LCROSS impact is a perfect example. We don't know exactly what we're going to find. Otherwise, why bother with the experiment, right? We have ideas and we have hypotheses, and we can do our best estimates of what we expect based on the knowledge that we have. And then we take that information and then try and go the next step and try and understand what's going on and what's happening. And so I've just always been fascinated with planetary science and with astronomy and physics. And so I think I'm very fortunate to be in a position where my job, I personally find my job very interesting, and it's always something different every day, and attacking these problems from a variety of ways, whether it's spacecraft data or it's going out into the field and doing field work, or whether it's numerical modeling or whatever it happens to be. It's always something different, and so I think that's pretty fun, and I'm glad I get to do it for a living. I think I'm pretty fortunate.
If
So
frozen
if
water
frozen
is
water
found,
is found,
where did it come
where did
from?
it come from?
Yeah, good question. So, why would there be water on the moon? So, there's a few different ways it could have gotten there. One, for example, is that we know that especially early on in the history of the solar system, several billion years ago, there were a lot more impacts going on. The solar system was still forming. There's a lot of debris that was going around. You can see, I mean, the evidence of that is apparent on the moon. That's why there are so many craters that are so old on the moon. It's because of this period when it was just being bombarded with materials. And so some of those materials that were hitting the moon and the Earth were comets and asteroids. And for example, comets are sometimes called dirty snowballs. Full of ice, they're full of water ice. And so that material hits the moon, and then you've got these cold traps near the poles where the sun doesn't shine at the bottom of these craters. And so it's a perfect place in which to trap water ice. So any water ice that might have been delivered to the moon would naturally tend to accumulate in these polar regions, which is why these areas are so special. So that's one of the ideas of where this water might have been delivered from. And it also plays into the delivery of water to Earth, too. I mean, we got our water from somewhere. So a lot of people think that comet and asteroid impacts early on in the solar system might have been a source for this water.
Hey, anybody else out there have a question?
Can we
Can we
calculate
calculate the speed of sound
by s?
by s?
That's funny.
Sorry, I missed that.
Oh,
I had a question asked
that I think
Stephanie was just making fun of me.
Okay.
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 Well, those were
really some great questions.
Yeah, those were excellent questions.
And so far, I've been getting some great comments, some good luck, some thank yous. This has been great. So yeah, I just like to repeat that. Thank you, Jennifer, for coming on with us tonight
and
giving us a great presentation.
Thank you.
I'm sorry,
I'm sorry, Jennifer.
Oh, thank you very much for setting this up and giving us the opportunity to talk.
Yes.
Yes.
Jennifer,
you could go ahead and
mute your
mic.
Sure.
That'd be great. That might.
Thanks. I'm not trying to kick you off. So I'd like to thank everybody for joining us tonight. This is by far, I think, our largest crowd so far. Hopefully that means the word's getting out in the future. Again, thank you for your questions. Thank you for joining us. 2 weeks from tonight, we will have Marjorie Wentworth, who is the Poet Laureate of South Carolina. She'll be here talking about how the moon has influenced her work in her poetry. Those of you maybe new to our webcasts or to My Moon in general, that's one thing we're trying to do with our webcasts is to get scientists like Jennifer on to talk about what they do. But also, we have other guests who talk about artists, poets, authors who talk about how the moon has influenced their work. Next week, we have a poet, like I say, Marjorie Wentworth. I'm sorry, not next week, but in 2 weeks. And then 2 weeks after Marjorie, it's about a month from now, on October 21st, we will have Dr. Barb Cohen will be here, and she will be talking about results from the LCROSS impact. So that'll be, but like I said, that'll be in about a month from now. I just want to remind everybody that we have started a blog on My Moon, so if you want to go and check that out and leave comments if you would like to. If you want to leave comments, you do have to sign up, which is no big deal. We don't ask you for too much information. We also have posted a new contest. I won't tell you too much about that. You just have to go check it out and see what it's all about. We'll have another contest shortly after this one, this current contest that complements the current contest, so to speak. So go to My Moon homepage and check that out. So thanks again, everybody, for coming. And we hope to see you in 2 weeks.